Okay, and welcome. So this is a short video on adding binary numbers, yeah? Let's first take a look at the binary addition rules. So just like when we have normal addition, we have a set of rules that we need to follow, right? So, and the binary addition rules are as follows. So we understand, first of all, that the language of binary, so if we were to say, well, binary only has the following elements. So we know that it consists of a language that has zeros and ones. So we should be able to do simple kind of calculations, and we just need to understand the set of rules that go with this, okay? So one of the rules, or the very first rule, is if we have a 0 plus a 0, well, this is equal to 0. If we have 1 plus a 0, this gives us a 1. If we have a 0 plus a 1, this gives us a 1. And we have 1 plus 1, well, this is equal to 0, but we have to carry the 1. Just like if we have a decimal, well, when we get past a certain threshold, we have to carry, I guess, into the next unit. So these are our fundamental rules of binary addition. Okay, so we should be able to use these rules now to be able to, well, run some very simple calculations. Okay, so let's take a simple example. So if we wanted to add the number, so if our question was, well, we want to add 10 base 10 plus 7 base 10, well, we know we should get the number 17 base 10. Okay, so that's effectively what we're trying to do here. Now, just in case you're wondering what I'm talking about by the base, well, the base is, or indicates, the number system. So we have base 10 is for decimal. Okay, and essentially why we would say it's base 10 is that we have 10 numbers. So we get the base from the number of elements in the language. So this will be for a decimal 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 10 elements, which is why we get base 10. Okay, so let's think about this for a second, okay? So the first thing we're going to have to do is, well, I want to take this this particular number here, 10, base 10, and I need to see what that is in binary. Right, so I know I'm trying to get down to this kind of particular question here is 10 base 10 plus 7 base 10 is equal to 17, right? So we know that, yeah? And this is our fundamental, I suppose, question, right? So we understand when we're adding decimal numbers, if we add the number 10 plus 7, we get 17. Now, when we look at our binary addition rules, we have the rules with how we can actually do this for binary, but we need to be able to now look at 10 and convert that into a binary number, take the number 7, convert that into a binary number, and apply the rules associated with binary addition, and we should get down to 17 base 10. Okay, so let's start off here. Okay, so when I'm going to convert 10 base 10 into a binary number, right? So if we take the number 10, we divide it by the base of the binary number system, so we divide it by 2, and now we get 5. And now we note the remainder, so remainder 0. Now, we take this number 5, we say divided by 2, this gives me 2, remainder 1. We take the 2, divided by 2, we keep dividing by the base, And 2 divided by 2 is 1, remainder 0. 1 divided by 2 gives us a 0 and a remainder of 1. So all we've done is divided these numbers repeatedly by 2, which is the base of binary. We get an answer, and then we get a remainder. We note the remainder. When we end up getting a 0 here, we stop, and now we read back up. Okay, so we read from the bottom up this way, and we get back 1 0 1 0. Now this is a base 2 number. Okay, so what we've just done is we've converted, and we can now say that 10 base 10 is actually equal to 1 0 1 0 base 2. Okay, so that's cool, right? So now we've just converted 10 base 10 into a binary number, which is 1 0 1 0 base 2. So the other number that we had was 7. So if we now take 7 and we do the same process, we say 7 divided by 2 is going to be equal to 3, noting the remainder of 1. 3 divided by 2 is equal to 1, remainder 1. 1 divided by 2 is equal to a 0, remainder 1. So again, we've reached the 0 here, and we have in the remainders, so we read back up, and we get 1 1 1 base 2. So what this tells us is that we have 7 base 10 is actually equal to 1 1 1 base 2. Okay, so now we have our two binary numbers, right? And now we want to perform the addition, right? So let's just say we want to perform the addition. So we have 1 0 1 0 plus 1 1 1. So let me just write down our actual rules again. So we know that 0 plus 0, this is going to be equal to 0. 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. 1 plus 1 is equal to 0. And then we have a carry, yeah? We say C1 or carry a 1, yeah? Okay, so these are the rules, and just to show you, these are the rules that are just simply up here, okay? So we've just taken them down a little bit. Okay, so now we need to perform this addition, so let's have a look at it, okay? So we say, well, 0 plus 1, this gives us a 1. 1 plus 1 gives us a 0, carry the 1. 1 plus 1 plus 0 is going to give us a 0, carry the 1. 1 plus 1 gives us a 0, carrying the 1. And then 1 by itself, we know that we can have a 0 here as well, or 1 plus 0 just gives us a 1. So what we have now is the number 1 0 0 0 1 base 2 is our final answer. Okay, so let's check, right? So we said that we wanted to actually end up with, well, we know that 10 base 10 plus 7 base 10 is equal to 17 base 10. Okay, so what did we do? Well, we converted 10 base 10 and we got 1 0 1 0 base 2 plus 1 1 1 base 2. We're saying this is now equal to 1 0 0 0 1 base 2. Okay, and this is what we've just done by following the binary addition rules. So let's just have a look. So what we'll do is we'll convert, right? So let's convert the binary number into decimal. Okay, that sounds like a good idea to me. Yeah. So if we grab this number here, so we have 10001. Well, the actual conversion into binary here is just what we call a position value expansion. Okay, and all we want to do is actually expand this number out, right? So it's a position value expansion. So, and how we do it is very simple. We take the binary number, we go to the least significant digit, which is this digit on the right. We write down a 0 above it. And now let's just write the indexes in increasing order from right to left. So now the process is actually pretty straightforward, very simple. So what we do is we take the number, so we say 1, we multiply it by the base of binary, which is 2, raised to the power of the index, plus 0 multiplied by, and all I'm doing is repeating this process, as you'll see, plus 0 multiplied by 2 to the 2, plus we say 0 multiplied by 2 to the 1, plus 1 multiplied by 2 to the 0. And now we just add up all these numbers. So the very nice thing about this is that it's a very simple process. We simply take the number, we multiply it by the base, raised to the power of the index. So if we were to just work this out, well, we have 2 to the 4 is 16, multiplied by 1 gives me a 16. 0 multiplied by anything, so we see the 0 here, multiplied by anything, well, it just yields a 0. So we can say 16 plus 0 plus 0 plus 0, because all of these are being multiplied by 0, plus, well, 2 to the power of 0 is equal to 1, right? And that's a rule that we can apply. So we can say anything raised to the power of 0 equals 1. So we have 1 by 1 gives us a 1. And now we can see that if we add up all these numbers, we have 16 plus 1, which is equal to 17 base 10, which is our answer. Okay, so we can see we introduced the laws. Let's just recap here a little bit, okay? So we go back to the very top. And we can say, well, what we want to be able to do is to calculate some kind of binary addition, right? So then what we did was, the approach that we took was we understood that, well, binary consists of only ones and zeros. We then looked at the laws or the rules associated with binary addition. So 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, and we carry the 1, right? So we saw how we could actually, at least formulate some rules around binary addition. We then took an example. So we said, look, let's take the two decimal numbers, right? 10 base 10 plus 7 base 10, and we know that that's equal to 17. We explain a little bit where the base comes from. And now we say, okay, well, let's convert those numbers into actual binary numbers so we can look at these binary additions. So we did that, and we took the number 10. So we say 10, and we say, look, we take 10, we divide it by 2, we get some answer, and we get the remainder. We repeat this process down until we get this actual 0 at the bottom. So we keep dividing it by the base of the binary number system. We get an answer and a remainder. And then when we get down to 0 here, well, then we simply just read back up this way and we note the remainders, right? So we read it out, we get 1 0 1 0. It's important that we read from the bottom up to the top. So at this point we actually said then that 10 base 10 is equal to 1 0 1 0 base 2. Deadly. We repeated the same process, converting 7 into a base 2 number, and we saw that 7 into the base 2 number then, so 7 base 10 was actually equal to 1 1 1 base 2. This was cool. Now we took then the actual I suppose binary addition rules again, and we just noted them down here just for clarification. So we have 0 plus 0 is 0. 1 and 0 is 1. 0 and 1 is 1. 1 and 1 is 0, carrying the 1. So once we then have the rules, we just apply the rules here and we follow down through the addition. So we said 0 plus 1 is 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 0 is 1. So we get our answer of 10001. So just to validate it, we just converted this binary number back into a decimal number, and we can see that we got our answer of 17 base 10. So this should help. I mean, you should understand now how to, I suppose, add some simple binary numbers. You should know the binary addition rules and be able to convert between decimal into binary and binary back into decimal. So now that we're finished, well, the only thing we have left to do is to draw a little happy face. Okay, thanks for listening.